Hi students, welcome to physics classes. Now today we'll discuss resolution of a vector. Resolution of a vector. Now resolution means the process of splitting a vector. Process of splitting a vector is known as resolution of vector. A vector is splitted into components. Means the parts after resolution are known as components of vector. A vector splitted into its components is known as resolution of vector. Now, if components of given vector are perpendicular, then those are known as rectangular components. Those are known as rectangular components. Now, we will see if vector A, this is the vector A in the xy plane, now it is making an angle theta with x-axis. It is making an angle theta with x-axis, and this is y-axis. This is a vector A bar making an angle theta with x-axis. Now it can be resolved into two components. One is x component, another one is y component. X component, another one is y component. Now here we will form a triangle like this. Now it becomes right angle triangle. Name O P. Here we can take Q. O P Q. Now if you take the triangle O P Q triangle, Q is 90 degrees. Cos theta equal to adjacent side OQ by hypotenuse OP. So from here we can write OQ equal to OP means A cos theta. So OQ we can write x-axis, no? AX. Component AX. Here it is AY. X component AX. X component of vector A is AX. Y component of vector A is AY. So OQ we can write AX equal to A cos theta. This is one component. Now I am taking sin theta here. What is sin theta? Opposite side PQ by hypotenuse OP. We can now PQ is parallel to y axis, no? So it can be taken as AY. So PQ AY equal to A sin theta. AY equal to A sin theta. AX equal to A cos theta. AY equal to A sin theta. Okay. Now here you will get a doubt. Always x component is A cos theta. Always y component is A sin theta. Is it correct? No. The component which making theta degrees vector is making theta degrees with one particular axis. That becomes cos, A cos theta, and another becomes sin theta. Instead of this, if they given like this, this is a vector A bar. It is making theta with y axis, x axis. Then it becomes A cos theta. It becomes A sin theta. Remember, for which it is making theta angle, that is cos component. Opposite one is sin component. Now once again see here, right angle triangle OPQ. OPQ is the right angle triangle. In this right angle triangle, theta is the angle here. Opposite side is AY. Adjacent side is AX. Why PQ becomes AY? It is parallel to Y axis. Y axis we have taken AY. So PQ equal to AY. Now magnitude of a vector we can take A. Now here if you take cos theta equal to adjacent side by hypotenuse. Adjacent side is OQ, hypotenuse is OP. Okay, now here you can write AX by A. AX by A. If you do cross multiplication, AX equal to A cos theta. Simply AX equal to A cos theta. At the same time, if you take sin theta is opposite side by hypotenuse. Opposite side is PQ, hypotenuse is OP. PQ by OP. Now instead of PQ, we can write AY. Instead of OP, we can write A. So again, if you do cross multiplication, AY equal to A sin theta, which is very, very, very important. Okay, AX equal to A cos theta, AY equal to A sin theta. And if angle is changed, components also changes. Okay. Now component along x-axis AX equal to A cos theta for a situation for previous diagram. Y-axis is A sin theta we got. Now if you take a vector A bar is making theta degrees with x-axis. This is AX is the magnitude along x-axis, AY is the magnitude along y-axis, and we know unit vector I along x-axis, J along y-axis. So A vector equal to x-axis magnitude and direction, y-axis magnitude and direction. Then instead of AX we can write A cos theta I, AY, A sin theta, J. Now to find magnitude of a vector, square root of AX square plus AY square, AX square plus AY square, and tan theta equal to tan theta opposite side AY, opposite side parallel to y axis, and x adjacent side AX, tan theta equal to AY by AX, magnitude and direction. Now if a vector A bar makes an angle alpha with x-axis, beta with y-axis, gamma with z-axis, vector A bar makes angle alpha with x-axis, beta with y-axis, gamma with z-axis. Then we can write vector A bar equal to AXI, AYJ, AZK. Now here AX, AY, AZ are components of along x-axis, y-axis, z-axis. Components along x-axis is AX, y-axis is AY, z-axis is AZ. Now we already know to find a unit vector, what we will do? A vector is divided with its magnitude. Now here vector is AXI, AYJ, AZK cap. This is a vector and its magnitude is square root of AX square, AY square, AZ square, sum AX square plus AY square plus AZ square. Like this we can find the unit vector also. And even already we discussed alpha, beta, gamma are the angles along x-axis, y-axis, z-axis of a vector a bar. Now here we can write ax equal to a cos alpha, ay equal to a cos beta, az equal to a cos gamma. Now these all are important relations. What I am saying here, magnitude of a vector, direction, and these formulas, unit vector, and these relations are important formulas. Now here we can write cos alpha equal to ax by a, cos beta equal to ay by a, cos gamma equal to az by a. Now from this we can say cos alpha equal to ax by a means magnitude of a vector, square root of ax square plus ay square plus az square. Cos beta ay by same, square root of ax square, ay square, az square. Sum. I am not saying plus. You should take it is sum. Then cos gamma equal to az by ax square, square root of ax square plus ay square plus az square. Okay. Now here from these cos alpha, cos beta, cos gamma, cos square alpha plus cos square beta plus cos square gamma. Now cos square alpha, cos square beta plus cos square gamma we can take 1 equal to 1. Cos square alpha means ax square by ax square plus ay square plus az square, square no, so root cancel, plus cos square beta ay square by same ax square plus ay square plus az square plus cos square gamma az square by ax square plus ay square plus az square. So if you take LCM, ax square plus ay square plus az square is LCM, then ax square plus ay square plus az square equal to cancel 1. From this cos square alpha we know sin square alpha plus cos square alpha equal to 1 relation. Sin square theta plus cos square theta equal to 1. Instead of theta I have taken alpha. Even you take beta, you take gamma also. So from this cos square alpha equal to 1 by sin square alpha we can write 1 minus sin square alpha we can write. You substitute there cos square alpha 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma equal to 1. 1 plus 1 plus 1 3. This plus 1 coming this side minus 1 equal to minus sin square alpha coming opposite side sin square alpha plus sin square beta plus sin square gamma. Minus sin square alpha coming this side plus sin square alpha, minus sin square beta coming this side plus sin square beta, minus sin square gamma coming this side plus sin square gamma. 3 minus what? 2. So sin square alpha plus sin square beta plus sin square gamma equal to 2. This is also very important relation. Cos square also important. Cos square alpha, cos square beta, cos square gamma, sum. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Sin square alpha plus sin square beta plus sin square gamma equal to 2. Okay. Now another one. If two vectors parallel to each other, for example, a vector is parallel to b vector. Now vector A, we can take AXI, AYJ, AZK plus B vector, we can take BXI cap plus BYJ cap plus BZK cap. Now if these two vectors are parallel, then AX by BX equal to AY by BY equal to AZ by BZ equal to constant. If they are parallel, equal to constant. If they are not parallel, anti-parallel, A bar is anti-parallel. A bar and B bar are anti-parallel to each other. Anti-parallel. Same. AX by BX equal to AY by BY equal to AZ by BZ equal to minus K. Negative constant. Now, if a vector is represented with xi, yj plus zk, xi cap plus yj cap plus zk cap, vector, any vector. Now its magnitude in xy plane is x square plus y square under root. Its magnitude in yz plane is y square plus z square under root. Its magnitude in xz plane x square plus y z square. Its magnitude in x y z plane square root of x square plus y square plus z square. X is a unit vector along x-axis. X is a magnitude along x-axis, y along y-axis, z along z-axis. Component. X is the component of a vector along x-axis, y is the component of vector along y-axis, z is a component along z-axis. Unit vector along x-axis is I cap. Unit vector along z-axis, y-axis is j cap. Unit vector along z-axis is k cap. Now its magnitude in xy plane, only xy you should take. Yz plane, yz you should take. Xz plane, only xz you should take. XYZ plane, all you should take. If a vector is in horizontal direction, now its vertical component 0. If a vector in vertical direction, its horizontal component is 0. So for any vector, its perpendicular component is 0. For any vector, its perpendicular component is 0. Okay. Thank you for watching. Please subscribe.